Let's take a look at a little bit of a more complex molecule here, which is ascorbic acid, or vitamin C. And this is a good example because it's starting to look a little more complicated, but not too much more complicated. But the reality is, if you know how to do assigning the hybridization this way, even if I gave you a 1,000 atom protein, you should still be able to get it completely correct. Vitamin C is a really important molecule to actually think about in terms of thinking about its shape and its hybridization. Vitamin C is an antioxidant, so we might remember that from when we were talking about free radicals. Free radicals can cause oxidative damage. These antioxidants, some of our vitamins, including vitamin C, are antioxidants. So that's something that a lot of people in the general population know if they're into their health. But another really important thing about ascorbic acid is that it's an enzyme cofactor. And a cofactor just means that it's some type of molecule or atom, in this case it's a molecule, that's required by an enzyme in order for the enzyme to carry out its chemistry. And the chemistry that the enzymes that vitamin C are a cofactor for are responsible for putting oxygen OH groups onto collagen molecules in order to form what is the collagen triple helix. And collagen is the main constituent of bones, of joints, of connective tissue, of many important structural parts of our body. So you can imagine that vitamin C is very important because we need to keep our collagen intact. Collagen is actually one of the most prevalent proteins in our entire body, and it makes up a large part of our cells. So you can imagine if we don't have collagen that is in this triple helix, we're going to run into some problems. Does anyone, or I'm sure many of you do know, but can someone tell me what the name is of the disease if you have a deficiency in vitamin C? Scurvy. Yeah, scurvy. So scurvy, most often associated with ships because of the 1500s and 1600s and 1700s, when boating technology was far above biochemistry technology. So people could make ships and go on these long journeys, but people did not yet understand they needed to keep certain vitamins in their bodies, such as vitamin C. Maybe also they didn't know about, well, they didn't even have the structure, so they couldn't have realized that vitamin C is polar and won't stay in their bodies for very long. It will get excreted out through their urine. So they were not thinking about how quickly they could run into trouble in these long sea voyages. And I don't know how many of you had a unit on explorers in elementary school. I did in 5th grade, and one that always sticks in my head is Magellan's trip around the world, who led the first fleet of ships around the globe. What they did not mention to us in 5th grade was that 90% of his men died on that journey. And you know, I understand we were young kids. I didn't want to know that at the time, but it's interesting and it's really important. And the reason for many of these deaths was scurvy. And it's totally preventable. And in fact, the cure for scurvy, which is as simple as taking vitamin C in any form, was known since the 5th century. People started figuring this out. But the problem was there was so much false information as well that it was not a general practice on ships to be treating men that were suffering with vitamin C or using it as any kind of preventative measure. The other somewhat interesting thing I want to say about vitamin C is that it was part of the first ever published clinical study. And this was a controlled clinical study that was done in the 1700s, the first one that's ever been reported. And not surprisingly, it was done on a ship, and it was done by James Lind, who was a Scottish naval surgeon. And basically, he took 12 of his men, so this was not a very large clinical study like they do today, but he took 12 men that were suffering from scurvy, and he gave them a diet, mostly of just carbohydrate mush, because when you have scurvy, one of the first signs is bleeding gums and teeth falling out. They couldn't really eat too much. But he supplemented their diet. He put them in pairs of 2 and supplemented with one of 6 things. So 2 of them got a pint of cider a day to see if that helped. 2 of them got half a pint of seawater, maybe not the best group to be in. Even worse group to be in is 2 of them got diluted sulfuric acid. Turned out that didn't help so well. Other things were some got spices, not so bad, and then 2 of them actually got citrus fruit. So no big surprise ending to this clinical study. The people with citrus fruit were completely cured and back to duty within a week. And I'm not sure exactly what happened to everyone else, but let's hope they got switched over as well. But it's just neat to think about, even back then, people were doing these controlled scientific studies. This was one of the first cases. Unfortunately, it was another 40 years between this study being published and the British Navy requiring supplements of citric acid. So really, we've come a long way in terms of disseminating scientific knowledge to the community, and that's a really important part of being scientists. Not just making these discoveries, but also passing them along, for example, to these ships full of people that need to know it. So in terms of scurvy, we don't see too much of it today. But who should be concerned about suffering from scurvy? Do we have to worry about our cats or our dogs at home? Are they getting enough of their vegetables and vitamin C? It turns out we don't have to worry. Primates are who should be concerned. So we need to be concerned. Other primates need to be concerned. It turns out that most other mammals actually biosynthesize vitamin C, so we don't have to worry about most of our pets at home. Unless you have a guinea pig, and they don't, in fact, biosynthesize vitamin C. So I think they supplement most guinea pig pellets with vitamin C, but maybe keep an eye on your guinea pig. We primates and guinea pigs are the only types of mammals that don't actually biosynthesize their vitamin C. So again, vitamin C is a cofactor. That means it needs to bind to an enzyme. It means that the shape of vitamin C and the hybridization are going to be really important.